Hello, welcome back to my channel. So this is part 2 of stoichiometry conversions. So the previous video we just did mole to mole, so like a one-step conversion in the train tracks. Today we will be doing 2 steps. So we'll do mole to mass and mass to mole. So make sure you have your periodic tables and calculators to help with the calculations. I'm going to start off with the mole to mass. And I will write down a chemical equation that we're going to use throughout. So let's say we have iron with nitric acid, and that produces iron 3 nitrate and hydrogen gas. And it is already balanced for the sake of saving time for helping with our conversions. So first off with mole to mass, we're going to start off with the given. So calculate the number of grams of H2 if 1.3 moles of, let's try that again, of nitric acid is used. Okay, so same strategy from, the mole ratio conversions that we always, again, I prefer like highlighting or underlining what you need to start with and then kind of boxing what you need to end up with. So basically, there are some questions that you'd be asked, like calculate the number of grams if 1.3 moles of HNO3 is used with iron. So sometimes there will be fluff, extra information in the question, but that's why I like to underline or highlight or circle what we need to worry about. So we have nitric acid, so HNO3 and H2 that we need to worry about. So these two things need to be in our train tracks. We don't worry about the other two. Okay, so that way you don't kind of put the wrong molar mass or anything like that. Okay, so we always start with what we're given, 1.3 moles of HNO3. Alright, and then again, units are very important, so I'm going to pull that unit down to the bottom right, mole HNO3. And it's, again, very tempting to just go directly to grams because you may be used to just the one step with the mole to mole, but grams, that is an extra step, so a 2-step. So before getting to grams of H2, we have to get to moles of H2 because mole ratio always has to be somewhere in the train tracks. It is basically the gateway or like the bridge to get to grams. So we're going to put mole, the unit mole, H2, and that'll help us to get to grams. And whenever you see mole over mole on both sides of the train tracks, that is the mole ratio. So we get those numbers from the balanced chemical equation. So mole of H2, I put 3, which is the coefficient in the equation, and then I have 6 HNO3. Alright, so this is what we did in the previous video, just mole of HNO3 to mole of H2. But since it's asking for grams, I'm going to add another step here to get to grams. Okay, so mole of H2, pull that down. And we want grams of H2, which goes on top. So units are pretty much done, and then you got to be careful on this last step of the numbers. So it's very tempting to put, oh, mole of H2, I need to put a 3 here. No. So whenever you have grams of anything, whether the grams is on top or on bottom, the opposite side is always 1 mole. Alright? Because the grams of any compound or any element it is the molar mass, and the literal definition of molar mass is grams per mole. So this is grams of H2 per 1 mole of H2. So grams of anything, we get that from the periodic table. So 2 hydrogens, that becomes 2.016. Again, as another reminder, hydrogen is 1.008 for 1 hydrogen. Multiply that by 2 for H2, and that's what you get, 2.016. The setup is done now, because again, when you cancel out the units, mole HNO3 cancels out, mole H2 cancels out, I end up with grams H2, which is exactly what it's asking for. And then you calculate, so 1.3 times 3 times 2.016, all that divided by 6. Then you plug that into the calculator, you should get 1.31 0. So that should basically round to the nearest decimal place, grams of H2. Alright, so that's the first example. The second example, I'm going to have you all try this by yourself. Alright, calculate the number of grams of iron 3 nitrate if 6.75 moles of H2 is produced. Alright, so when you see the question here, FeNO3, so iron 3 nitrate grams is what we're looking for, and then we're given 6.5 moles of H2. These two is the only parts of the equation that we're using here. The reactants, we don't even look at that. Alright, so pause the video, try it by yourself, and then unpause to check your work. Alright, so you should be getting like a big number here, which makes sense because the molar mass of iron 3 nitrate is a large number, and usually moles is a small number, but I gave you a pretty sizable amount of moles, so you should be able to get 1,088.357 grams of iron 3 nitrate. Again, make sure you have your correct units, so I like to set it up as unit here, diagonal, unit, new unit, diagonal down, etc. Alright, so this is mole to mass. Now, with mass to mole, it's essentially just backwards, but same rules apply. And I'm going to use the same equation here. Let's say I give you calculate the number of moles iron 3 nitrate when 3.82 grams of HNO3 is used. Again, kind of highlight what we know from the question. We are given 3.82 grams of HNO3. We want moles of FeNO3. So, HNO3, FeNO3. These two are what we're looking at. Alright, start with what we know. Alright, so now this time we have grams HNO3 pull that down, the unit, grams HNO3. So a common mistake is that you'll put a 1 gram, but no, grams of anything, no matter what, always use the periodic table. So the molar mass of HNO3 is 63.012. And then molar mass is grams per 1 mole, so that goes on top, 1 mole of HNO3. And then that is basically the gateway to get to moles of iron 3 nitrate, or nitrate, excuse me. So mole HNO3, pull that down. And then mole of our product here, mole of iron 3 nitrate. And this is my mole ratio here, mole over mole, and we use the coefficients in our chemical equation to figure out our numbers. So I have 2 for the iron one, and then 6 for the HNO3. We'll cancel our units here. And this is exactly what we're looking for, which has us to solve. So 3.82 times 2 divided by 63.012 times 6. So if you like to punch everything at once in your calculator, which I highly recommend you don't, I highly recommend just calculate step by step. So in case your calculator doesn't know how to PEMDAS, so I would add parentheses. So parentheses 3.82 times 2, parentheses, divided by parentheses 63.012 times 6, parentheses. So it's annoying, but the parentheses, so if the parentheses annoys you, that's when you do the step-by-step calculations. So when I calculate that, you should get a pretty small number because you're dividing by a bigger number, which is 0.0202, and then it is mole of iron 3 nitrate. And that's it. Same process, just the other way around. I'll give you another problem to try by yourself. Calculate the number moles of iron if, let's say, 16.5 grams of H2 is produced. Alright, so I hope you have the equation written out because, you know, gotta scooch over. But go ahead and try this by yourself. Again, highlight what you know, what you don't know, and go from there. Pause the video, try it out, and then unpause to check your work. Okay, you should have gotten as your final answer 5.456 moles of iron. So you start with the mass of H2, you use the molar mass of H2, so 2 hydrogens per 1 mole, and then you carry the mole down here, and then we're trying to find a mole ratio according to our equation here, 2 iron, 3 H2, and then when you calculate, you should get this final answer. Again, when you I would multiply across, multiply the bottom, top, divided by bottom. Alright, so that is pretty much it for 2-step conversions on mole to mass, mass to mole, both ways. Alright, and stay tuned for my next video, which is kind of the longest versions when we do mass to mass. But I hope this helps, and hope you have a wonderful day.